Hey everyone, welcome to our next unit on properties of angles and triangles as we start to get into a little bit of a idea of some angle properties as well as some trig. And so we'll start off, so in this unit basically we're going to be proving different properties of angles get formed by intersecting lines, so lines that cross. We're going to be proving properties of angles that are used in triangles and other polygons, so your squares, hexagons, octagons, and shapes kind of leading up and increasing in side numbers. And as well, we're going to use properties to solve some geometric problems. So similar to other units, I'd encourage you along the way to pause the video, jot down some notes, especially the definition terms that we start to encounter along here. It'll come in handy quite a bit later on as you start to make connections between what you see and some of the questions that are being asked. So, some geometric properties, hopefully a little bit of a review. Specific names are given to specific shapes, and so when we talk about polygons, poly really is just a prefix that just means many. So poly just means many sides, and they have all shapes with straight sides. And so circles, for our purposes, for instance, won't be included. Same thing with half circles and that kind of stuff. So we start off, we've got triangles, they have 3 sides, quadrilaterals 4, and you can kind of see the list as it moves down the downward. We can really go up 9 sides, isn't shown on here, but 9 sides would be a nonagon, with nona, N-O-N-A, being the prefix, and 10 sides would be a decagon, as we have decade, meaning 10. So, or 10 years, sorry. So we can increase in our side values and kind of increase in our shapes as we start to move through there. So some different types of quadrilaterals, also just meant as a little bit of a review to get into. We have a square, we have a rhombus, a rectangle, a parallelogram, and a trapezoid. And so as we kind of take a look at our different shapes, remember our square has 4 equal sides to it and 4 right angles that come off of it, kind of defining what our square is. A rhombus would have our 4 equal side lengths, but it doesn't have the angles like a square does where they're 90 degrees, they're tilted. And so opposing angles would actually be equal to each other in angle measure. Rectangle special because it has 2 sides that are the same and 2 opposing sides that also share the same length. They have right angles. And a parallelogram has 2 side lengths that would be the same, opposing side lengths that are the same, but there are no right angles in this case. It would be similar to our rhombus, where we have opposing angles kind of representing or totaling certain values. Okay, so these would be the same moving in, and opposing angles would be the same as well. And then we have our trapezoid that really has 2 different side lengths that are the same, which would be these 2. And it has some different properties with it in terms of angle measures that are the same, as these 2 would be the same angle measure, and these 2 would be the same angle measure. So, some different characteristics of some of the different shapes, just things for you to kind of note as we go through. Triangles, they can be classified by the length of their sides. They could also be classified by the measurement of their angles. And so if we were to look at them by the length of their sides to start off with, there's 3 main ones. We have a scalene triangle, which has all side lengths different. That's the reason why it has kind of one with 1 line, one with 2, and one with 3. Then we have an isosceles triangle, where it has 2 side lengths that would be the same, and 1 side length that would be different. And then we have an equilateral triangle, where all 3 side lengths would be different. If we were to take a look at them from the measurement of their angles, we have an acute angle, which is an angle that is less than 90 degrees. Then we have a right angle, which is equal to 90 degrees. And then we have obtuse, which is greater than 90 degrees. And so you can kind of see those angle measures inside the triangles that can also define them. Where the obtuse angle would be like right here, our acute angle would actually show up in any of the 3 main ones that are there, any of the 3 angles that we have, and our right angle is normally denoted by that box that just kind of tucks within a corner to show that it's 90 degrees. So we have some different parts of angles. We have a common endpoint, which we call a vertex. And so to name this angle, we use certain terminology. And normally what we do is we start at what's called a ray, and rays are just lines. When two lines connect together, that's where we get this vertex coming from. And so to name the angle, we use stuff like angle ABC, where we would basically say we're going to start at A, we're going to go A to B to C, and then it makes the angle that's in here. Okay, so it could go this way. Likewise, I could start this off and say, okay, well, I don't want to go A to B to C. What if I went C to B to A? So, okay, we're going to go C over here to B and up here to A. And so we'll take a measure of the angle that forms in between. So really, both of them are correct. And really, the middle letter is saying what it is that we're looking at for the angle, which is the reason why sometimes it's simply just called angle B, okay, or the angle itself. But all three of them would be acceptable. It's just in terms of what it is that we have to describe compared to when we would use them. We have some geometric properties. And so again, if you haven't been copying along the way, I would really encourage that you copy down some of the property values just so you can go back and reference them as we're going through everything. So we have complementary angles. Okay, so a complementary angle, this would involve a right angle, and it would say that if I take A plus B, it's going to equal 90 degrees. So complementary means that they're working together, they're going to add together. Now a supplementary angle would just mean that they're adding together to make 180 degrees. So again, they're helping each other out, adding together to make 180 degrees. So these happen when I have a straight line, and I have a line that cuts that in some form. So complementary, 90 degrees, adding together. Supplementary, 180 degrees, adding together. A couple of geometric properties. We have opposite angles that are the same. So in this case, if I have any two lines that ever intersect each other, their angles are equal to each other. So in this case, A is just equal to B. So if this were 40 degrees, then this one would be 40 degrees as well. We have the sum of the angle in a triangle theorem. It's normally, you might see it as SATT, sum angle triangle theorem. So all of the angles in a triangle add up to equal 180 degrees. We also have the isosceles triangle theorem. And this one kind of has a little bit more of a roundabout way to go through it, but it's understanding isosceles triangles mean that two side lengths are the same. And then since, if we follow this, since DE, so the line D to E, right, so this line right there is equal to FE, so this line right here, so as long as DE is equal to FE, then angle D is equal to angle F. Okay, so our isosceles triangle theorem can help us a bit too. And really, then we can kind of use that sum of the angle in a triangle theorem. And if we know angle D and angle F, then we can figure out angle E, because 180 subtract those two would give me what that missing angle would be. And then finally, we have a exterior angle theorem. And so exterior angles, this one will say that if I have a triangle and I know two angles that are in here, so let's say I knew angle A and angle B, those two will add together to give me the outside angle, angle ACD. Okay, in this case, I need to be really specific to what I say here, because I can't just say angle C, because that could mean inside the triangle, and that's not the one I'm talking about. So this one comes about because we know that all three angles, okay, A plus B plus C, have to add together inside the triangle to equal 180. And if I know two of them, then the remainder, angle C, is really just 180 minus angle A and angle B. And then from there I have this idea of a straight line, and straight lines add together to make 180, and so the outside angle must then be A plus B together. So that's a little bit of an exterior angle theorem, okay? So it has to be the opposite two angles will let me find the angle outside of the one that I don't know. Okay, and again, we need to be specific, and we need to say where it's heading, A to C to D, because in this case, if you just wrote angle C, maybe some people might think it's A to C to B, right? And that would be inside the triangle. Then we have our last one, sum of the angles in a quadrilateral. So A plus B plus C plus D will equal out to be 360 degrees, and that'll come in handy as well, just like our triangle does when it adds to 180. So that's our first one. We'll pick up with the next one when we start to go through some things on parallel lines.